Hi, welcome to the Mission Control Center in the International Space Station Flight Control Room in particular. And we, as I mentioned earlier, are going to have a special guest joining us from Kennedy Space Center today, Dr. Paul Schallhorn, who is working on the next iteration of the Spheres experiment. That's the synchronized position, hold, engage, reorient experimental satellites that we talk about really a pretty good bit. They do a lot of work with that on the space station and have been for a number of expeditions. They found a lot of different ways to use that technology and perform different experiments with it. And one of them is going to be going up next week on board Cygnus to the space station. That's the one that Dr. Schallhorn is working on. I believe he's connected. Dr. Schallhorn?
Yes. We have an experiment that's going up to station that's going to be using spheres to capture fluid motion inside of a small acrylic tank, a Lexan tank. The thought for us is, I work in launch services program. Our primary purpose is launching of most of the science missions, and many of the launch vehicles we use have liquid upper stages. And during our launches, the liquid upper stage will end up usually having a coast period, and during that coast period of microgravity, we're concerned with what is happening in the fuel and oxidizer tanks of those upper stages. So in order to understand that, excuse me, I'm sorry, go ahead.
No, that's okay, go ahead.
I was just going to say, so during that coast phase, liquid's moving around, we're wanting to know what's going on, and we predict it using numerical tools called computational fluid dynamics. But we don't have any real test data in which to anchor these models. So this experiment is giving us all the test data that we're hoping to use to simulate what happens to the propellant tanks on our vehicles. We're using this to anchor our modeling methodology, if you will.
So how is this different than how you're able to test it on the ground? What do you gain from testing it in space?
Well, where our concerns are is we actually have gone and done a whole series of tests. We've sponsored it. The Launch Services Program, with me as PI, has sponsored the Florida Institute of Technology, specifically Dr. Dan Kirk and Dr. Hector Gutierrez, to perform a whole series of liquid slosh maneuvers. Sloshing basically meaning liquid moves around in a random fashion. And so we've sponsored it on the ground, we've sponsored some zero-G flights, but our biggest concern has always been what happens when you're in a microgravity situation. Upper stage fires, it shuts down as it coasts, getting ready to do another firing to send the satellite into whatever orbit or trajectory that it needs to go into. And so our concern is what's happening during that time frame. From a vehicle controls perspective, is sloshing around and overtaking the vehicle control system. From the area that I have interest in, what is it doing to the conditioning of the propellant? Will it be able to fire as needed?
Great. So where did the idea of using the Spheres satellites on the space station for this experiment come from?
That's a good question. A number of years ago, when we were in the midst of doing a lot of our ground testing of slosh, the folks from MIT came down, specifically Dr. David Miller, and he was the person at MIT that heads up the lab that developed Spheres. And he was coming around to show us what Spheres was. When he came around and showed our group, the first thing that came to my mind is this is the next logical step that we can end up using to advancing our understanding of liquid behavior during the coast phase. So I got Dr. Miller and Dr. Kirk together to start postulating how could we end up doing an integrated slosh modeling capability using Spheres and using some of the expertise that was developed by Florida Tech.
What were you able to figure out? How's the experiment going to work?
Well, the experiment that you see that'll be going up, and hopefully have a picture of this, has two of the spheres that are at the end of two long arms, and in the middle is a tank that is clear that's filled with liquid water that has a food coloring in it.
We've got the two. I think that's a little bit better. The two satellites, I guess, on either end, the red and blue. And the tank is in the
Yep.
middle?
Yes. And then the tank has 2 cameras pointing at it, and so we can know where the motion is at any given time, because we have accelerometers on board. And so we know what, let's say, the impulse is, and we're using spheres in this case just as our propulsion system. And then we'll end up having it go through a set of maneuvers typical of those of an upper stage, and we'll watch through the 2 cameras that are mounted 90 degrees apart. They're kind of sitting up on an arm, to look down into the tank and see how the motion goes. Then we'll compare that directly to our modeling simulations.
And so the main idea is to verify the simulations that you've already modeled.
Right. Our concern is there some physics that we are not currently capturing. On the ground, everything seems to be dominated by gravity, but when you get into a microgravity situation, our concern is the things such as surface tension dominating. Is there something else in the physics that we don't know? So we just want to make sure we have a good, proper understanding before we end up using this modeling tool any further in launches that involved multi-million-dollar to billion-dollar satellites. And so it's our way of trying to get a good investment for what we're doing in the future.
Sounds like it's worth getting that exactly right. So when will we?
Yes.
Let's see. We expect it to launch next week on board Cygnus, and then when will we actually
Correct.
be seeing the experiment start on board the space station?
I believe that the first round of experiments is going to be starting sometime in the mid-January time frame, and then we have 2 more experiment sets coming up in February and March. And then based on the result of those, we'll end up evaluating and see if we can end up asking for additional test sessions.
All right. Well, we'll look forward to seeing those. Thanks so much for talking with us. We really appreciate it.
Great. Thank you so much.